Good morning, gentlemen. We're going to go ahead and continue our discussion of acids, bases, and pH. Did pretty well on the quick quiz yesterday. As of the time of this video, 90% of you had done 70% or above, and many of you got 100s, and a lot of, one or two misses. So we're going to continue on. Quick review on what you've already learned. We know that pH is equal to the negative log of the hydrogen ion concentration. And of course, my pen's messing up. So that's what pH is equal to. pH equals the negative log of the hydrogen ion concentration. And if you know the hydrogen ion concentration of solution, it's easy to solve for pH. Hit log in your calculator, type in whatever the hydrogen ion concentration is, take the opposite sign. So it's easy to solve for pH if you know hydrogen ion concentration. If you know the hydroxide ion concentration of the solution, you can still solve for pH because you can convert or use the hydroxide ion concentration to solve for hydrogen ion, because we know that the ionization constant for aqueous solutions is 1 times 10 to the negative 14th. So we know 1 times 10 to the negative 14th is equal to the hydrogen ion concentration times the hydroxide ion concentration. So if we know one of these, we can solve for the other. So if we know OH, we can solve for H. If we manipulate that equation around, hydrogen ion concentration equals 1 times 10 to the negative 14th divided by the OH. And that's what you spent Tuesday doing. And it appears that most of you have that down okay. If you don't, you can always get a hold of me for some more practice. So what we're going to do now is, what if we know the pH? What if we have a pH meter and we stick it in a solution? Can we use that pH to figure out how many hydrogen ions are in there? In other words, the concentration of hydrogen ions. And the answer is yes. If you know the pH, you can use the same exact equation to solve for hydrogen ions, right? And I'm going to show you two ways basically to do it. They're both the same thing. Whatever works best for you, go ahead and use, depend on your understanding of logarithms. So if you understand logarithms, you can do it this way, and even if you don't understand logarithms, you can still do it this way as long as you follow the method. So let's just say that we know the hydrogen ion concentration is 0.1. So this is 0.1. So if we take the negative log of that, we would get the pH. And if we punch that into our calculator, of course, we get 1. Negative 1 when we punch it in, but the negative of a negative is 1. So the pH equals 1. Well, if you didn't know that, if we knew the pH was 1 and we didn't know the hydrogen ion concentration, to solve for it, we would just do this. We could take 10 to the negative pH equals our hydrogen ion concentration. These two equations are saying the same exact thing. pH equals a negative log of the hydrogen ion concentration is the same thing as saying 10 to the negative pH equals hydrogen ion concentration. So if we know pH, we can use this equation to solve for hydrogen ion. So let's just check our problem we're working on. So if we didn't know this was 0.1, but we did know the pH was 1, I'm going to fix that equal sign. 10 to our negative pH, so a negative 1, because there's our pH 1. So a negative pH equals 0.1. 10 to the negative 1 is 0.1. So you can simply use this equation right here to solve for hydrogen ions if you're given the pH. Okay, let's do another one real quick then. So let's say we know the pH of a solution to be 5. The question is, what is the hydrogen ion concentration? Well, we can just take 10 to the negative 5 equals our hydrogen ion concentration. And that's an easy one. Whenever the pH is a whole number, it's an easy one. We can do that in our head. We don't have to punch that in a calculator, but if you want to, you can punch it in your calculator. 0.0001. Or you can punch that into your calculator by hitting 10 and then your little symbol like that, negative 5, and hit equals, and you're going to get the same thing. The calculator might show it to you in scientific notation and just show you this. But the concentration of hydrogen ions in a solution with a pH of 5 is 0.0001 moles per liter of hydrogen ions. Now, of course, we're not always going to have a pH of a whole number. So what if we had like pH equals, I don't know, 6.2? Well, we do exactly the same thing. We would take 10 to the negative pH, which is 6.2, and punch that into our calculator. Now this one you can't do as easily in your head. So when you punch it into your calculator, you would type in 10 and then that little symbol like this, negative 6.2, and hit equals, and the calculator is going to tell you that it equals 6.3 times 10 to the negative 7th. That would be the concentration of the hydrogen ions. One more, pH equals, we'll do a high pH, 12.4. So we know we have a very basic solution. So if the pH is 12.4, what is the concentration of the hydrogen ions? Again, all you have to do is take 10 to the negative 12.4, punch that into your calculator, and that equals 3.9 times 10 to the negative 13th. You can spot check these real quick. Whatever the exponent is should be fairly close to what your pH was, or at least a negative. Right? Okay, so given pH, you can solve for hydrogen ion concentrations. Okay, the other way you can look at it, and it's essentially exactly the same thing, if you'd rather punch it into your calculator this way, let's write our original equation. pH is equal to the negative log of our hydrogen ion concentration. If we want to solve for pH, or excuse me, for a hydrogen ion concentration using this pH equation, another way to manipulate it around is just move all this to the other side. And to do that, we'd have to get rid of our negatives. So first thing we'd have to do is make it a negative pH. And then if we want to get rid of our log, we're going to have to take the inverse log of this side. So the equation turns into this. So inverse log of negative pH is equal to the hydrogen ion concentration. And it's exactly the same thing as saying 10 to the negative pH equals a hydrogen ion concentration. If you rather punch it into your calculator like this, you can. You would have to find your inverse log button. For a lot of calculators, that's a second function log. So you'd hit second function log of whatever your negative pH is. And essentially, it's exactly the same thing. But if you rather do that on your calculator, you're welcome to. Okay, so today and tomorrow, I'm going to give you 2 days to do these problems. So Thursday and Friday to do these problems. You're going to solve for hydrogen ions given pH. So once you've done that, there'll be a few generalized problems. They can consist of anything we've done on acids and bases so far. So there will be a key available. Use it wisely. Okay, good luck.